Hello students, today we will learn about solution, colloids and suspension. Now, in your previous classes, you have studied about the solution. Water solution you study, the solution is a mixture of solute and solvent is called solution. Suppose, for example, you have salt solution, right? Salt solution, you have taken a beaker, in a beaker you dissolve salt, right? And salt dissolve in water. So the water is called solvent, right? And the salt is called solute. Solute always present in a small quantity, right? Is a small in a smaller quantity, and similarly the solvent is always present in larger amount or larger quantity. Here I will show you. This is the ready-made salt solution I have made. Okay, you can see there are certain points like you cannot see the salt particles dissolve in the solution. That means the size of the salt particles or solute is very small in the case of solution, and the solution looks transparent. That means we can see across through the solution. Is it clear? And there is no visible boundary, there is no separation, there is only one mixture we can see, there is no separation, right? In the next cases we will get the separation. Now, so here 3 points I have discussed. The first thing is size of particles. Size of particle is very small, right? Or we can see smallest, that is 1 nanometer. 1 nanometer is equal to 10 raised to power 9 meter. Is it clear, students? Second point we have seen, it is a homogeneous mixture. Homogeneous mixture means the solid particle is evenly distributed, right? The third properties or characteristic we have seen, that is there is no visible boundary. Between the solution and the solute. That means they look one. That is stable. It is stable. Now the next thing is it is a transparent solution or transparent. Next thing, it doesn't show Tyndall effect. Tyndall effect, that is when light ray pass through the solution. When light ray pass through the solution, it directly pass. The light ray is not scattered. When the light ray will scatter, when the particle size will be larger. The size of the particle is so small that it is not hindering the way of light. So light will directly pass across the solution. Is that clear? So what is Tyndall effect? Tyndall effect is when the light rays pass through the solution, any solution, right? And the particle of solute, right? Solute particle are able to scatter, यानी क्या करेंगे, बिखेर देंगे लाइट को. So that is called Tyndall effect. But in the case of solution, the particle size is very small. They are not scattering the light. That is why the Tyndall effect is not shown by the solution. Is it clear, students? Now we are going ahead. Another concept also you can see. I am just going to make the ink solution. Only 2 drops of ink I have drop down into the water. You can see, even though I am not shaking the solution, but still the ink is spreading throughout the solution by their own. Why? What is this process? In the previous video I have shown this process is called diffusion. In the diffusion, the solute particles are automatically diffuse in throughout the solution or throughout the state. That means when the particles move from higher concentration to the lower concentration by their own is called diffusion, right? Again, if you wish to see, I will show you again. See here, this time only one drop of uh, ink I will drop. See, the clear case of diffusion, you can see the particles are always in the motion, whether it is present in the solid, liquid or in the gaseous state. Right? The particle of ink, you can see they are automatically moving. That means they possess the kinetic energy, whether they are in the liquid state, solid state or gaseous state. This process of moving from higher concentration to the lower concentration by their own is called diffusion. I hope it is clearly understood. And it is also called a solution. When we pass the light through it, what will happen? It will not be scattered, right? Similarly, in the next session, in the next one, that is colloid, that we are going to study about. Colloids. What are colloids? Colloids are also mixture, but they are heterogeneous mixture. They are heterogeneous mixture. What does means heterogeneous? That means the component of the mixture is unevenly distributed. Unevenly distribution. That means the component of mixture is uneven distributed throughout the mixture. If we are talking about size of particle, the size of particle will be 1 nanometer to 100 nanometer, right? That means they are large enough from the solution. They are heterogeneous, right? And visible boundary. There is no visible boundary. Visible boundary, if we are talking about the visible boundary, in the case of colloid, we are not able to see the visible boundary. No visible boundary, right? It will look like a solution. For example, see, I have taken the milk. Milk is a colloid solution, right? So in the milk, the component are not visible, and the size of particle will be larger than 1 nanometer. That means if we pass the light through the milk, it will scatter the light. That means they will show the Tyndall effect. Why they will show the Tyndall effect? Because of this only. This is very important factor in case of colloids, right? So they are not very small. They are larger than the solution. They are large enough to scatter the beam of light, and that is why they will show the Tyndall effect, right? There is no visible boundary. They are transparent. No, they are not transparent. They are opaque, or you can say sometimes translucent. They will be opaque or translucent, right? And there is no separate visible boundary. They cannot even, you see, separation. They will separate it by centrifugation. What is centrifugation? You might have seen the washing machine. After washing the clothes, it has to be dried, and in the dryer, when you put the clothes in the dryer and spun, what will happen? Dryer ghumta hai na, that is called spun. It is spun, it rotated so fastly. In that way, the larger the heavy particles getting into the downward by spun, and they have been separated. That means the liquid is heavy particles in the clothes, so when you spun, all the liquid forcefully they have been settled into the bottom, and from bottom it is drained. The washing machine is one of the beautiful example. Now separation is by centrifugation. That means the separation of the colloid particles. We cannot separate the colloid particle by sedimentation or by filtration. Similarly, in the case of solution, we cannot separate the particles by filtration, centrifugation or sedimentation. Why? Because they are very small and we have to go for the evaporation and condensation, etc. Now moving ahead into the third category, that is called suspension, right? Many times you might have heard this word suspension. Suspension also, they are also mixture, but in the case of suspension they are heterogeneous mixture. That means the particles are unevenly distributed throughout the mixture. Size of the particle will be कितना हो जाएगा इसमें more than 100 nanometer, more than. Clear students? Now visible, here I made the chalk solution, right? The chalk already I have dissolved. Visible boundary, see here you can clearly see the visible boundary. The chalk is here, right, and other part is there. It is already sedimented, right? So in that case it is a translucent, not opaque, right? Many times I already told you colloid suspension may be opaque or translucent. Here you can see, we can see the visible boundary. The size of the particle is so large that we can see by unaided eyes or naked eyes. ऐसे ही हम particles को देख सकते हैं. अलग अलग boundary दिख रही है हमको, right? So the size of the particle is very large as compared to colloids and solution. I hope it is clear. And it can be separated by the sedimentation. हम इसको sedimentation से इसको separate कर सकते हैं. Clear? So here you can see visible boundary. Yes, they are visible boundary separated by sedimentation और decantation कर सकते हैं. Sedimentation और decantation और loading से भी हम इसको क्या कर सकते हैं? Separate कर सकते हैं. Opaque or translucent. Tyndall effect, yeah, this when it is mixed. See here, if I mix the complete solution, right, what is happening? It will be acting as the opaque material, so the light will not be pass. But once it settle down, then what will happen? The light will be pass and scattered by the solvent of the suspension, so it will also show the Tyndall effect, right? Now we are moving ahead into the comparative study, right? Comparative study. In the comparative study you will easily identify and able to learn what is actually comparison amongst the solution, colloids and suspension, right? The first point, see here, homogeneous. Solution is homogeneous mixture, colloid is heterogeneous mixture. Here we can write 2 points, homogeneous or heterogeneous. Clear students? So it is homogeneous, heterogeneous. It is homogeneous. It is heterogeneous. It is heterogeneous. Clear students? This is first point. The next point, you will see the size of the particles, right? The size of the particles. The second point, particle size, you can say particle size. Here the particle size is 1 nanometer. Here the particle size is 1 nanometer, 200 nanometer. Here the particle size is more than 100 nanometer, right? So next 100 nanometer. Next one, you can see sedimentation. If we are talking about the sedimentation, sedimentation is shown by the solution? No, it is not shown. Not shown. Colloids will show the sedimentation? No. Suspension will show the sedimentation? Yes, suspension can show the sedimentation. Next, it can be separated by the filtration. What can be separated by the filtration? The solution cannot be separated by the filtration. The colloids cannot be separated by the filtration, but the solution and the suspension can be separated by the filtration. Now next is Tyndall effect. Tyndall effect. See, Tyndall effect is not shown by the solution, but it can be shown by the colloids and as well as suspension. Right? Are you able to see the visible boundary? Visible boundaries. In the case of solution, there is no visible boundary. In the case of colloids, also we cannot able to see the visible boundary, but in the case of suspension, we can see the visible boundary. Another term we can see centrifugation. Centrifugation is shown only by colloids. Solution and suspension cannot be separated by the centrifugation. If we are talking about components, right? What are the components in the case of solution? They are solute and solvent. Here it is disperse phase or disperse medium. That I am going to explain you. Disperse medium. What are disperse phase and disperse medium? It is also disperse phase and disperse medium. See, here I have chalk solution. It is a heterogeneous mixture. Here you can see one thing is present in the smaller quantity. In the case of solution, that we say it is a solid. But in the case of suspension and colloid, we will say it is a disperse phase. Clear? And the next component which is present in the large amount, that is called solvent in the case of solution. But here in the case of colloids or suspension, it is called disperse medium. So simply, when you are looking into the solution, in the solution, right, there are salt solution. If suppose salt solution, there are solute and solvent. Here the solvent is called disperse medium. Remember, and here it is called disperse phase. So you will not get confused. The solute is called disperse phase. The solvent is called disperse medium in the case of colloids and suspension. I hope it is clear. For this, an example also you can consider. Example, here you can take the example 9th one. Example, salt solution. Right, here you can take the example. I have shown the milk, the fog. Right, they are the colloids. Also emulsion is also act as a colloid. Here you can see many examples. Soil plus water. I have shown the chalk plus water. Is it clear? And many medicine also comes. Liquid medicines you might have seen. Liquid medicine written with the label. Suspension, I will show the example. I have, see here the Calpol is one of the suspension. Here you can see what is written. It is written suspension. Right, it is paracetamol for the pediatric use, and it is suspension. Right, are you able to see suspension? Similarly, you can see, I also have another example. It is clearly seen. suspension. What are suspension? Now you can understand very much. Thank you for watching this video. Hope you like it.